So now that we've talked a bit about what flatMap does, let's compare and contrast it with map. So we're going to talk about that, and we're also going to talk about the Project Reactor flatMap concurrency idiom. So flatMap is often, though not always, used when the items emitted by a stream need to be run in their own thread of control. So let's take a look at an example here. And this is what's known as the flatMap concurrency idiom. And let's see how this works. So we're going to take a list of big fractions and turn it into a flux of big fractions. And then for each of the elements in that flux, we're going to use the flatMap concurrency idiom. So the way to look at this, the way I kind of think about this in this context, is flatMap is kind of like a for loop, except it's not a for loop in the traditional sense. It's like a parallel for loop. And what it's going to do is it's going to iterate through each of the elements in this flux stream of big fractions. And for each of the elements, it's going to go ahead and multiply the big fraction by some constant. And it's going to do that in a parallel thread pool. And we're going to talk about the parallel thread pool here shortly. So this is a parallel thread pool that comes out of the box with Project Reactor as one of the schedulers. It's pre-built into the scheduler's utility, Java utility class. And what it's going to do is it's going to arrange to multiply each of the big fractions in this stream against some constant. And it'll do all those things in parallel. So you can think of this as sort of like again, like a parallel for loop in a reactive way. And what will happen then after all the concurrent processing completes in this flatMap is that we're going to take all the results and then we're going to reduce them together to add them up into a single final reduced result, which is the final sum of all the big fractions that were just multiplied by some constant in a pool of threads. So that's what this is doing. So that's one way, not the only way, one way you can get concurrency in Project Reactor using fluxes. And you'll also notice we use monos here as well. Let's now compare and contrast map and flatMap. Anybody who is into old school 1960s, 1970s toys remembers Rock'em Sock'em Robots, which were this funny game that you would play. They were actually physical plastic robots, and you'd box them and you'd knock their heads off. It's kind of funny when you were like 7 years old. So the map operator, if you recall, transforms each value in a flux stream into a single value, one at a time. And therefore, it works in a one-to-one way. Every input item is mapped to an output item. And it's really intended for synchronous, non-blocking, one-to-one transformations. And what that means is it's not running in the background. You could also use it for blocking stuff if you wanted to, but we're trying to avoid blocking as much as we can. In contrast, the flatMap operator takes each of the values in a flux stream and converts them into an arbitrary number, 0 or more values. So that's why you can see that you can end up with more or less, or the same, output values from flatMap than you get from input values. Whereas with map, as you can see up here in the image, in the marble diagram, it's a one-to-one mapping. And therefore, it's often intended for asynchronous 1 to n transformations, where n can be 0, n can be 1, n can be greater than 1, and so on and so forth. And after doing the transformations, then the little steamroller comes along and flattens everything out, so you end up with a stream of the results, not a stream of structured results. You don't end up with a stream of lists of things, of strings, whatever. You end up with a stream of strings that have been flattened. flatMap is very, very popular in Project Reactor. You see it used all the time. And it's interesting because when you are used to programming with Java streams, you'll often use map. It's very, very common. And you sometimes use flatMap, unless you're trying to do parallel processing, in which case you should use map multi. But with Project Reactor and RxJava, for that matter, flatMap is the go-to transforming operator. So you'll get a chance to play around with that. It's actually quite cool, especially when you combine it with the flatMap concurrency idiom that we just talked about. As we will see here, probably after spring break, there's another way of getting parallel processing with Project Reactor, and that's using something called a parallel flux. And a parallel flux, as you may recall, is very similar to a Java parallel stream, but it's just ever so slightly different syntactically because of the way that Flux is and reactive programming is designed to work. So that's the end of the comparison of flatMap with map, as well as a discussion of the flatMap concurrency idiom.